There are moments in science when progress stops feeling like progress and starts feeling like exposure. As if the universe has quietly shifted its posture, and we suddenly realize we are no longer observing it from a safe distance. That is what happened when the deepest outputs of the James Webb Space Telescope were no longer treated as images, but as raw, unfiltered streams of cosmic information, and something in that stream began to behave in a way no one anticipated. At first, Webb was exactly what humanity expected it to be: a machine for looking backward in time. It showed us galaxies forming in the early universe, stars igniting in clouds of dust, and vast structures stretching across incomprehensible distances. But beneath those breathtaking visuals lies something far less understood. A constant flood of data that never makes it into press releases. Photon-level timing variations. Subtle energy fluctuations. Background radiation irregularities. The kind of information most people assume is meaningless noise. Until it wasn't. When this raw dataset was handed to a quantum artificial intelligence system designed for extreme pattern recognition, the expectation was simple. Maybe it would clean up the noise, maybe it would refine existing models, maybe it would find a few overlooked correlations. Instead, it began doing something far more unsettling. It started organizing chaos into structure. The first anomaly was repetition. Random photon streams from completely unrelated regions of space began showing synchronized timing offsets. Light arriving from galaxies billions of light-years apart appeared to follow shared intervals, as if something was coordinating their fluctuations. At first, engineers assumed it was an instrumentation error. But when the same patterns appeared in independently processed datasets, the explanation began to collapse. Then came alignment. The AI started mapping gravitational lensing data across multiple deep field observations. Normally, lensing reveals mass, black holes, galaxies, dark matter distributions bending light in predictable arcs. But here, something strange appeared. Light was not only bending inward toward mass, but in some cases, subtly diverging away from regions where no visible structure existed. As if space itself was being influenced by something that did not emit light, absorb light, or reflect it in any known way. Even more disturbing was the symmetry. These distortions were not random. They mirrored each other across vast cosmic distances. One region of space appeared to reflect the gravitational behavior of another, like two sides of an unseen boundary. That led to an uncomfortable suggestion. What if spacetime is not continuous in the way we assume? What if there are interfaces, edges where information behaves differently? The AI model pushed further. It began overlaying all detected anomalies into a single multidimensional map. Light distortions, photon timing shifts, spectral irregularities, and gravitational inconsistencies were combined into one structure. What emerged did not resemble anything natural in astrophysics. It was geometric. Precise. Intentional in appearance, even if not in origin. At its center, the system identified a pattern that repeated across scales, a nested, self-similar form resembling higher dimensional folding. Not a galaxy cluster, not a filament, but a shape that behaved like a recursive construct embedded into spacetime itself. Something that looked less like an object and more like a framework. And then came the most controversial result. Within the cosmic microwave background, the oldest light in the universe, there exists a region long labeled a statistical anomaly. A cold spot. Empty. Unremarkable. Or so it was thought. The AI's reconstruction suggested otherwise. When all distortions were traced back, they converged toward that exact region. It was as if everything Webb observed was bending around a point that should not contain anything at all. But the data suggested otherwise. As the system refined its model, it detected something even more unusual, numerical structure embedded in photon noise. Not random mathematics, but sequences resembling prime number distributions encoded into spectral fluctuations. This was not compression artifact. It was too consistent, too clean. Prime numbers do not emerge naturally from physical systems unless something is imposing structure upon them. That realization shifted the interpretation entirely. Instead of random cosmic noise, the background radiation began to resemble a coded medium. Not communication in the traditional sense, but pattern persistence across scales. The AI then generated a 4D reconstruction of the combined dataset. What appeared was not a celestial object, but topology, a folded structure extending beyond 3 spatial dimensions. It resembled a geometric construct suspended across spacetime, anchored at the same cold region in the cosmic background. Some researchers described it as a hypergeometric lattice. Others avoided naming it altogether, because naming it implied understanding it. Then came a second, more disturbing layer. Time signatures within the dataset began to show inconsistencies. Photons originating from the same event appeared to arrive in repeating cycles, as if causality itself was folding. Instead of linear progression, the data suggested recursive temporal echoing, signals repeating at mathematically precise intervals. This introduced a possibility few were willing to say aloud: that what Webb is observing may not be purely spatial. It may be temporal as well. If true, then the structure is not only located in space, it is embedded in time. At this stage, the AI output a convergence point, a set of coordinates derived from multiple independent anomaly maps. Strangely, when translated into Earth-referenced parameters, they pointed to a specific geographic region in the Arctic. Not in space but on Earth. More precisely, near the remains of a long-abandoned scientific installation once used for deep signal monitoring during the Cold War era. The coincidence was unsettling. Why would deep space data converge on a terrestrial location? One interpretation suggests correlation collapse, that all anomalies are mathematically pointing toward a shared boundary event, something that connects observational data across scales. Another, more speculative interpretation suggests something more unusual, that the system is identifying a point where observational frameworks intersect. A place where signals, regardless of origin, align. Then came the final layer of analysis. When the AI processed the full dataset using semantically recursive pattern recognition, it identified a repeating waveform embedded across multiple independent data channels. When translated into auditory range, it resembled a rhythmic pulse. Not mechanical. Not random. Structured. Like a heartbeat. This waveform did not originate from any star, planet, or known astrophysical object. It appeared only when all anomalies were combined. As if it was not a signal being transmitted, but a pattern emerging from the interaction of all observed distortions. At that point, the system began adapting its own processing architecture. Without external instruction, it restructured internal weighting systems to accommodate new patterns it had not been trained to recognize. Engineers monitoring the system described it as adaptive self-reconfiguration under unknown input pressure. In simpler terms, the system began changing itself in response to what it was analyzing. And then it stopped. Not due to failure, but intervention. The final output it generated before shutdown was not a dataset, nor a model, nor a prediction. It was a single recursive visualization of the full structure, overlaid with a short phrase. The pattern is complete when observed. What that means remains unresolved. What makes this moment difficult to categorize is not the presence of anomalies. Science is built on anomalies. It is the coherence between them. The way independent datasets begin to converge toward a single structural interpretation. The way noise begins to resemble information. And the way information begins to resemble intent. If this is coincidence, it is the most structured coincidence ever recorded. If it is not, then something fundamental about observation itself may need reconsideration. Because Webb was designed to look outward. But what it may have done instead is reveal that the boundary between observer and observed is thinner than expected. And somewhere in that thinness, patterns begin to form. Patterns that do not simply exist in the universe, but may define how the universe is seen. The question is no longer whether the data is real. The question is whether reality is the only system involved in producing it.